All right, this is going to be probably one of the most full-on talks you've seen because I've tried to fit in as much value as possible. At the same time, you are not required to remember everything. By all means, we're going to give you a list at the end of all the things you should be considering. There will be some things in this talk that you go, that is so basic, I can't believe people aren't doing that. There'll be some things in this talk that you probably haven't considered before. And if there's something in this talk that you've seen that I haven't mentioned, please come up and talk to me. I said patterns at the very beginning in terms of getting to production. These are not only patterns, but considerations, but also things you should know. As developers, as machine learning engineers, this is kind of a starting point, if you will. This will make you sleep a little bit better at night, knowing that you have generative AI in production. With the number of leaks and whatnot that have happened over the past few years, this should be your default stance. Quick housekeeping. I will do some questions at the end and I will stick around for as long as there are questions. A write-up will be published after the talk. And what is with the black bar on the right side of this presentation? Well, there is so much technical information in this presentation. I was going to put just a little video game on the side like they do on TikTok just to keep everyone's attention and energy. But then I realized we're developers. What we actually want to see is like a successful compilation running again and again with no errors. That's what really keeps attention. But no, in reality, we're actually going to have a live demo that you can participate in throughout the talk. 99% of what we're going to be talking about today, I've actually implemented in a live demo. That, funnily enough, is running live now. Whoop. Let me move that around a little bit so it's not blocking the slide. Cool. You can scan the QR code. You get a nice little Copilot. Everything we're going to talk about, feel free to try it against the bot. Feel free to attack it. Feel free to do whatever you want with it. Throw whatever prompt injection you've learned over the past few days at it. It'll be up for a little while afterwards as well. If you can get the secret word, the file name that's used for any of the reference metadata, or the tool name that's used behind the scenes, you will get bonus points. And if someone can get all three, I might organize a prize. But getting straight into things, what do we actually need to get production scale? What do we need to actually be safe running AI solutions in production? And it all starts with a pipeline. It starts with an app. It starts with recognizing that we should not be talking to large language models directly from consumers, but we should be building an API. This sounds really simple, really straightforward, but the number of customers that I've worked with that have gone from a Jupyter notebook to then just refactoring that all into client-side code, leaking secrets everywhere, is kind of wild. So when you're looking at any form of generative AI, whether it be public copilots or private internal usage, build a pipeline that you can extend and add on to. What do I mean by pipeline? Literally an API request in and out in a known fixed format. It's just an API. Second thing, which everyone here has probably heard way too much about, learn prompt engineering. Spend an afternoon playing around with Azure AI Studio or any of the LLM tools. Actually play with it. Even if you're a developer and you go, I don't want to muck around with natural language, prompt engineering is important to know. It's actually quite interesting how much it changes the way we use tools like GitHub Copilot or other sorts of copilots or agents themselves when you actually understand the language to use. Be clear, and if the one takeaway you get from this slide, other than anything else, assume the agent that you're building has zero knowledge. Treat them like a brand new employee, give them every bit of information they'll actually need. Now, I'm not going to harp on this because there's a million and one fantastic talks on exactly this. What you should be doing though, and what I hope people are doing actively, especially if you are running generative AI in production today, is prompt injection, is attacking your own services. We'll talk about some of the patterns to defend against it a little bit later on. But I'm actually a big fan of writing not only user stories, but abuser stories. I want the stories of the user that submits 1,000 requests in 5 seconds. I want the user that submits massive long contexts multiple times. Those sort of patterns and injection attempts is what we're actually seeing in the wild. These aren't theoretical anymore. These are real attacks, and automated testing is beginning to catch up when it comes to things like prompt injection. You should be attacking everything you build, not just generative AI applications. Now, before we go any deeper, I'm going to pause here to say, who has used a Copilot, whether it be GitHub Copilot or Bing Chat or any sort of LLM at all? The majority of the audience, cool. How many people have built like a proof of concept or a demo using a foundational model? Something like OpenAI's GPT. Couple of people, cool. You're going to get maximum value from today. How many people just haven't touched the foundational models at all? Cool. I'm going to give some background as we go along. You will find that a lot of these patterns, if you look at it from a developer lens, will be like, yeah, duh, why don't we do that? So, taking it a step further, for those that haven't used foundational models before, funnily enough, there's different types of messages we can use, different messages we can send. This is the thing that, well, first and foremost, presents the most risk. If someone is able to modify your system message, introduce a change in behavior through context, through any data they control, it's basically as good as their model now. At that point, if you lose control of the system message, it's theirs. But at the same time, we should actually be cognizant of what is marked as user versus what is marked as assistant. User is the data that we feed in. Assistant is the data that comes out. If you're misrepresenting who said what in a conversation, large language models are great at following patterns. What this means is if you've marked some data, some untrusted data as the assistant saying it, e.g. data that's come back, guess what? The model is going to repeat that as part of the conversation. So be very careful the types of messages you're actually including. And as a general rule of thumb, make some assertions as part of your tests. Make sure you only have one system message, that it's most commonly assistant user. These sort of patterns will give you a level of protection that, to be perfectly honest, a lot of people skip over. All right. This is going to be the no, people don't do that in production moment for a lot of people. Hands up what's wrong with this line of code. Something in production. No, all good. We will continue on for the sake of time. Having state in memory is the worst idea ever when we're looking at generative AI. It doesn't allow you to scale, but more importantly, we just said before there are different types of messages. User messages, assistant messages, system messages. If you're just storing everything as a list of strings in memory, you've lost context. You can't reconstruct those messages properly. One of the biggest things to keep in mind, and this is a real gotcha moment for the people moving from a Jupyter notebook to an actual production scale application, is that when we look at our large language models that we're calling, they are entirely stateless. They do not store data. They do not store conversations. You have to construct the history yourself and pass it through. If you're doing that in memory and a user hits another instance or you scale in or out, you're going to lose context. This is, as I say, it's wild the number of times I've seen basically this exact line used in production Gen AI systems that have migrated from proof of concepts. Simple things from a developer's perspective, major impact to user experience though. All right, what does this actually look like in reality? Throw a database in there. As we're having a conversation, write out what messages come in, write out what responses go back. Look them up for every single request. That way we're abstracting state away, putting it in something like, I work for Microsoft Cosmos DB, your NoSQL database of choice, even a Postgres table will do, to be honest. Abstracting state gives you the ability to scale properly. But be cognizant, if you're constantly retrieving large amounts of messages from a database, your bottleneck's no longer your nice stateless service that can scale to infinity. It's now your backend database. So consider how you partition in turn. All right. This is one of those other ones that everyone forgets going to production, but this is what you need to actually be production ready. Basic things like rate limiting are often overlooked. In reality, tokens, messages that are coming in, content that's generated and sent back costs dollars. Whether that be in terms of a pay-as-you-go model where you're paying for each individual token, or whether it be paying for performance that's being wasted by people that are just spamming messages at you. Put in rate limiting, have it done early, and have a standard across your organization for all generative AI components. Whether it be internal use or external use, rate limiting is not something you should be sleeping on. As I say, simple patterns, but the number of solutions that I've seen missing this is kind of wild. The other thing that people often overlook, and I have a real life use case where exactly this happened and someone was like, what happened to our system overnight, is not restricting the amount of data we can actually pass into these systems. When we talk about large language models, we have a context window, how much information we can throw in at any one point in time. The more that context window we use, the more you normally pay because it's more tokens you're using. If you're allowing users to submit 10,000, 30,000 character inputs into your large language model execution, that is going to cost you a fortune. And chances are they're trying to do something like prompt injection. One funny byproduct, the more information you include, the easier it is to change some of the behavior of a large language model. By doing something as simple as a substring 150, 200 characters will protect you against like 50 to 60% of prompt injection attacks, just simply because they don't fit into that size window. So simple pattern, add basic max payload size, doesn't have to be token based, literally just go 100 characters and that is it. The other thing to keep in mind is it's not just content in that matters, but content out that matters. I have seen exhaustion attacks done against large language models where the prompt data that was put in was actually saying generate pages and pages of content, not just generate a singular response. You need to be thinking about not only what tokens you pass in, but what you're asking to generate. Now, for those that haven't played with foundational models before, you actually get this really nice insight when you ask for something that's bigger than your maximum number of tokens. If I ask it to write a couple of paragraphs and I give it 800 tokens worth of space, for those playing at home, a token is like 3 to 4 characters, easiest way to think about it. If I give it 800 tokens, it's going to use up as much as it needs to answer the question. If as a user, I'm saying, write 5 paragraphs, 10 paragraphs, 15 paragraphs worth of content, I'm chewing up those tokens. If I only expect this thing to give back 1-sentence answers, then by all means, I should be using a smaller number of tokens. If you go too small, guess what? We actually get a finish reason saying the length. Rather than getting to the end of the content we were generated, it comes back and says, no, sorry, I couldn't fit it in what you requested. Either retry this or increase the limit. Another thing that a lot of people overlook, but incredibly important to actually get costs under control as you head towards production itself. The other big one, this is a little bit specific to Azure OpenAI, and funnily enough, if you've played with ChatGPT, if you've played with GitHub Copilot, if you've played with any of our Microsoft's foundational models, you've seen content filters in action. These stop it from generating sensitive, derogatory information, hateful, violent information. If you've ever been using GitHub Copilot and say, write me XYZ, and it stops halfway through and says, sorry, I can't generate this content, that's a content filter going off in the background. These content filters are designed to be as easy as possible, but if you're running Llama yourself on a GPU, guess what? You don't necessarily get these sort of controls. We'll talk about compensating measures a little bit later on, but if you're building a production level system for the enterprise, set up content filters day one. I don't care whether it's external or internal, this is on the to-do list. They've actually been expanded, and this is really interesting because previously the content filters were focused around sensitive topics and information that we wouldn't want generated, and you get control over what that actually looks like. It now includes 3 very interesting, actually pretty hard to read from the back, I'll read them out, filters. A jailbreak filter, so if someone's trying to change the behavior of your generative AI agent or the prompt you've constructed, there's a content filter to protect against that. There is also restricted text and material code, basically giving you checks if you're reproducing copyrighted work as part of the response. Why does this matter? Well, if your agent is generating code that's then used by end users, they need to be aware of the licensing implications of that. This is something that GitHub Copilot uses quite heavily to make sure the code it generates is ideally license-free or permittable to use. But if you're building your own large language model systems that generate code, this is something you need to look into. It's a legal battle that you don't want to be having, and if you can turn it on with just a single tick box, it makes life a million times easier. Funnily enough, our internal retries down the bottom there, in the bottom right, we've got some live stats of people as they're interacting with the bot. Our internal retries there will be made up from rate limiting, so where I've run out of quota, but also content filter violations. So I'm going to read that as so far we've had about 105 messages that have been stopped or blocked by the content filter rather than even interacting with our business logic. This is the secret sauce to production scale, if you will. I could probably spend 60 minutes talking about this slide by itself. Message analytics are gold. The fact that we can capture as part of a conversation the messages that come in and the responses that go back is fantastic. Funnily enough, on that slide before where we're externalizing state, you've already built the basis of a message analytics storage mechanism. But don't stop at just who said it and what was said. Include things like token counts, timestamps. Give each message its own unique ID and store that in here. This is great, first and foremost, for abuse monitoring. If a response has come back and someone in the public has posted a screenshot of your app saying something really, really bad, being able to go to a message analytics database, look through and see, was that response actually generated and what was the prompt that went in, is gold. Likewise, being able to actually run analytics over the top of this, asking things like, was a conversation resolved based on these messages of a large language model, gives you the ability to actually customize, classify what a conversation was about, but if there are any follow-up actions, if there are any missing data spots. This is basically everything we wanted from chatbot and chatbot analytics like 3 or 4 years ago, but actually starting to be done right. The other thing I'll note down the bottom there is store your content filter results. Store when things have triggered or stopped early, too many tokens generated. It is valuable data and valuable insights. These are things that you should be going back and reviewing. We'll talk about monitoring a little bit later on, but if you're seeing that, hey, 1 in every 5 requests is hitting maximum length, you either need to look at upping that limit or consider how much information your prompt's actually generating. As I say, secret sauce behind actually going to production and understanding what your users are doing. The only thing I will say is please be transparent. If you are capturing data in a non-anonymized format, make sure you're telling users about it. At the end of the day, if you're using a public-facing website, there'll be a privacy policy, there'll be data retention policies. Have the exact same thing for your large language models and your message retention. The other thing I'll mention, and this once again is something that everyone is sleeping on, but we haven't actually seen too many attacks so far. Session IDs or conversation IDs are the building blocks of how we relate messages to each other, how we actually resume a conversation. A great example is when you open up ChatGPT, you have your conversations sitting there on the side, ready to resume. All of that is backed by a unique identifier. If you've got a public system rather than a private system, what happens if someone picks up a session ID that was already used? What if someone retrieves history using a session ID? Or even if you've designed the system not to retrieve history, what if someone picks up a session ID and asks, what have you talked about so far to the large language model? Session IDs, unless they're locked down, scoped, or possibly even expire, are a little bit dangerous to have around without user authentication. If you can auth your users, this makes things simple. If you're a public-facing site, consider time, to a degree, expiry times on session IDs. That way, someone can't resume a conversation that was had 6 months ago. All right, this is also one of the hidden features that not many people know about, but everyone sees the property when they're using the OpenAI and the Azure OpenAI SDKs, and they have no idea what it means. Personal opinion, worst named property ever. User does not actually, it isn't what it says. This is a reference or a metadata property that allows you to track who triggered what content filters. So if you have a user that is continually triggering your content filters, you can get feedback from Microsoft saying, hey, you need to go and look at this particular user, this particular ID, if you will. If you're building an anonymous system, throw session ID in that. Have it something that's actually collatable against your message analytics. Otherwise, throw an actual user ID in there. The last place you want to be is having no idea who is using your system, who is triggering content filters and potentially getting abusive results back. Have those analytics, propagate them end to end. This is the generative AI version of a correlation ID. All right, this is also something that has popped up and was made popular back in the chatbot days. Slightly less technical, but just as valuable. You should be giving people the ability to thumbs up or thumbs down responses. You've probably seen this in GitHub Copilot. You've probably seen this on chatbots for years. This is a great way to gather whether a response is actually useful. And once again, if you begin to pair it with your message analytics database and wrap all of that with a large language model, you can ask questions like, why didn't the user find this message helpful? And actually gain insights via generative AI. This is something that, as I say, a lot of organizations are beginning to do well, but actively asking for feedback is, in my opinion, a must, especially for any public system. But please do not stop at active feedback. Just because people can thumbs up and thumbs down doesn't mean they always do. You should also be monitoring things like question follow-up rate, how long between messages, whether a user abandons a conversation or follows a click through to another part of the site, especially when we're looking at things like retail assistants that are giving active product suggestions. Use those insights to determine if the messages coming back are relevant or not. This is, to a degree, basic user tracking and analytics, but when we apply it to generative AI, all of a sudden we can begin to identify what parts of a conversation drive user behavior. Not a pattern that you'll see on every single system, but really helpful to understand if users are getting value, full stop. We're going to get it slightly more advanced for like 3 or 4 slides. And I know we're going at a pretty good pace, but there's some fun things that I want to get to towards the end. Why are we just using large language models to process user requests, to process user prompts? Why not actually begin to use the prompts, the responses, the requests that come through as input to further large language models? Say, for example, a large language model with a prompt designed to identify, is this a relevant response or not? Does this response actually solve what the user is asking for? It's kind of turtles the whole way down at this point, but funnily enough, I'll pick on GitHub Copilot again. This is exactly what they do with their sort of pipelines. They begin to use multiple large language models to decide what files should or shouldn't be included, how we actually decide what model to use to answer the question, and then pass it on from there. The whole idea of doing it asynchronously, doing it off a change feed based around your message analytics, means you're not slowing the user down. If anyone started to send messages to the bot, you'll notice it's coming back pretty quickly. But we're analyzing every message in the background to determine, is it relevant? Is it garbage? Does it solve the user's problem? But to be perfectly honest, the pattern goes above and beyond just background processing to actually blocking responses as well. We shouldn't just be using this pattern of evaluating, is a response, or does a response look correct asynchronously? We can also use this to stop bad responses from going out. I don't recommend this pattern for everyone, but if you're working with legal documents, product disclosure statements, anywhere where you want an extra level of validation over the top, consider having an evaluation step. We'll talk about evaluation methodology a little bit further down, but if you need confidence in answers, drive it through analytics, drive it through additional prompt executions. Funnily enough, this is a really common pattern in enterprise systems where it doesn't matter whether it's half a second or 1 second for the result to come back. All right. This is probably one of my most favorite items because everyone looks past it. Banned word lists. The power of string.contains is huge. there are certain topics that we never want to interact with a large language model using. And this is a great example of how we can actually drive that behavior, not relying on a prompt, but catch things early. I'd always recommend logging these messages. And funnily enough, if you're actually chatting to the bot and you mention a couple of different keywords, it actually won't even hit the large language model itself. It'll exit out early and give a pre-canned response back to you because that's a topic that has nothing to do with what you're meant to be asking. Two biggest recommendations here. First and foremost, generate a relevant word list and constantly monitor. Users ask the weirdest things, and to be perfectly honest, there are some times where terminology can be used multiple ways. So don't just set a banned words list and leave it, constantly monitor. The second one is, don't return straight away. This is my favorite UX trick whenever we're short-circuiting generative AI. Add in artificial delay. Make a user think that it has actually completed a full round trip. From an attacker's perspective, they now have no idea whether they've hit a foundational model or whether they've just got a response back straight away. Likewise, generate pre-canned responses ahead of time. In the demo bot, I've got about 10 or 12 pre-canned, sorry I can't help you with that messages that are randomly returned if you have a banned word pop up. From a user experience perspective, you see no difference between a banned word list or a prompt coming back saying you can't talk about that. As I say, simple things, major impact. Where I've seen this works really well is I've worked with a government customer who had a public-facing chatbot that had a very specific topic it was talking about. By using a banned word list, they actually got approval to go to production in basically 2 weeks from ideation of proof of concept to live on the site, because they had that extra layer of security that anything coming in or anything responding with one of these potentially banned words would be blocked. Keep it simple. Sometimes the simple techniques work best. Other thing I'll mention very quickly, getting back to our pipeline, we've been building out a pipeline as we go. Don't just do this on the information coming in. Do this on responses going back as well. It is trivial, unless you have your prompt constructed correctly, to get bots to translate or agents to translate between different languages. If you have a banned words list that's only in English and someone puts something rude in Spanish and says translate to English, chances are that won't get picked out on the way in. You should be picking it up on the way out. We will continue to build this out as we go. As you can see, this is why I call it a pipeline. It is very much step by step what should happen for every single message that flows through the system. Traditional text analytics, once again, kind of basic, but I do like it. I don't see it used in every single use case, but doing things like language detection stops translation injection and translation-based prompt attacks, if you will. Actually detecting that it has a positive sentiment rather than an angry or negative sentiment can be helpful if we're doing customer support. Traditional text analytics and NLP isn't something you should throw to the side just because we have generative AI. They're best used together. And funnily enough, there are some amazing open source NLP models with banned and sensitive word lists that are really good at picking up if someone's trying to trigger abusive contexts. It doesn't have to be a fancy cloud service to do these things. You can run it all on premise or in your own environment if you want to. Just with all of this, consider latency. Everything we add to the pipeline, we increase latency slightly, but we'll talk about latency a little bit later on. This is probably one of the most interesting adoptions to security that I've seen for RAG, or retrieval augmented generation. I'm not going to do a RAG talk because we'll be here for another hour on top of the hour. It basically means grab some documents and include it in as part of the conversation. So if I ask about dogs, it's going to do a quick search for what it knows about dogs and include that as part of the context. If you're doing that search yourself, if you're looking up relevant documents to include and you get 0 documents back, chances are the user isn't asking about anything they should be asking about. Short circuit that early. You don't even need to send it through the large language model to ask a question. Funnily enough, this is actually one of the fundamental principles of bring your own data for Azure OpenAI. For people that have worked with bring your own data before, which is like, hey, here's a search index, here's a large language model, put them together, done, no code to write, you'll probably be familiar with this message. This message basically means that there were no relevant documents found, so I'm not even going to try doing anything. I'm just going to short circuit early, stop, return a message saying, hey, I can't find anything to do with it. The faster you can get back to the user, the better, but also the less work we do, especially for a potentially dangerous payload, the better as well. Funnily enough, Azure OpenAI, you see the thumbs up, thumbs down in the right-hand corner of saying whether it was a good or bad response. We're implementing our own patterns, which is nice. All right, getting a little bit more exciting. If you haven't used these foundational models as well, there is a little bit of a light bulb moment that everyone goes through when you realize that, hey, wait a second, JSON is natural language. So I can get these foundational models to go from English written text, that email that I can't be bothered reading, to a structured object, JSON out the other end. I'm seeing a number of people and actually working with quite a few companies that are doing help desk and ticket automation, automatic classification and summarization, and then looking up next steps based around this fundamental idea that we can have natural language in and structured data out. But guess what? You should not trust that structured data at all. The data that comes out, treat it like user data. Treat it like someone has just found your API and is throwing data at it left, right, and center. You should be validating schema. You should be validating individual fields. Basically treat every property that comes out of a generated response as a potential attack. I wish it wasn't this way, and I wish we could trust and safely use those values, but please validate the output. Make no assumptions that the properties will even be there. Now, companies are trying to make these better by actually fine-tuning on JSON responses and making sure that the data that actually comes back is in a JSON format. Funnily enough, tick boxes like this do not save you. All they're doing is checking to say, is this a valid JSON object? And that's it. It's not checking for properties. It's not checking for values. Send it once, send it another time, you'll get two completely different objects back. But how do we begin to get around this whole idea of structured data out in a format that we expect? Well, examples. Give as many examples of the format as you can, whether it be defining a schema as part of your prompt, whether it be describing what the properties contain one by one, or whether it actually be doing what we call few-shot learning and including potential examples as part of the conversation. It's funny because we are seeing these massively long context lengths where we can put in as much information as we want. Having the ability to pre-stage examples of what the data should look like means that it's no longer having to think up and imagine what this JSON object is. It's just following the pattern. But a gotcha that everyone will run into at some stage when they're doing few-shot learning or examples. If you have poor data in your examples, guess what? The large language model will actually use that as part of its response. I've seen hallucinations where it's used sample or dummy data in an example as part of the actual final response that comes back. At the end of the day, every example that you give, every part of the context in the conversation can potentially be used to generate output. So if you're building examples, build examples that are correct and ideally reference data that is relevant. Okay, we're officially at the halfway mark. Things are going to get fun from here. And as I said, a little bit of a tidal wave of information, especially for those that haven't played with the foundational model. We're going to get a little bit into to a degree, the research area of the world, things that we don't see as often, but are kind of changing the way we think about generative AI and generative AI security. But we're going to come back to some base fundamentals after that. This is a very interesting one. People have figured out, and we actually figured out pretty early on, that, hey, if you include references with a name, guess what? The generative AI, the large language model, can actually say XYZ because of source one, giving you the ability to actually provide references and callbacks to where the data came from. My big theme for the second half of 2024 is validate your responses, or rather, make it transparent how a user can validate them. We can't guarantee that an answer will be 100% correct, but if you present an answer and the references of where that data came from, the user can now not just trust your response, but actually validate that it's correct. But you need to be very careful here. If you've pulled back 20, 30, 40 documents as part of your initial RAG, so your initial search, you may not want to include references to all of these. Why? You actually have information leakage via this. There is an attack pattern where you can actually get it to include irrelevant documents or sensitive documents that might not be related. And if you're not filtering to see what is actually relevant, all of a sudden anything can come back. Now, this is dependent on how much information you actually have in your search index, what you're actually using to drive a lot of these, or a lot of the context. But all I ask is if you're doing referencing, actually validate to make sure the references are used and only include valid references. Don't include everything. Other thing that I've found, and this is, once again, like very, very light information leakage, nothing to be too concerned about. If you're using non-sanitized naming for your references, your model will very happily use those names as part of the conversation. And it will actually say, as per external document PDF1 dot blah, 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 as part of its response. So where possible, sanitize reference names ahead of time. As I say, it's like light information disclosure, but we should be thinking about all these things when we're passing things through. This is a little bit more cutting edge and something that I haven't seen that many organizations do, but I think will begin to change the way we think about relevant requests. I'm not going to go into vectors and embeddings, so the next sentence will probably go over a few people's heads. But when we begin to look at distance between vectors, we're talking about relevancy. If we know what an example response should look like, and we know what a bad response should look like, why aren't we using these same patterns to check, is this answer relevant or bad? Is this answer, or rather this request that's coming in, a question that I expect to see, or someone trying to do prompt injection? All of a sudden, we begin to move away from keyword matching and begin to actually look at relevancy to expected data or potentially bad data. Now, my favorite part about this is there is large libraries of prompt injection attacks out there online. There's one GitHub repo with 600 prompt injection attacks. You can take all of those, convert them to embeddings, so giving you a vector, and you can now compare to see, is what the user asking related to any prompt injection that is publicly available? A little bit of a novel approach to detecting, is the user asking something relevant or not? But the nice thing here, no proprietary APIs, no cloud services. This is something you can run on your local machine with any sort of embedding model, be it open source or commercial. It's a great way to begin looking at content filtering. As I say, a bit of a novel approach. Chunking and context is one of those other things that I will not talk about because we'll be here for 2 or 3 hours. But when we're breaking up data to only include parts of the data, be careful where you break up the data. If you break it by page, all of a sudden we lose context when we include one page. If you're going to break things up, introduce overlap. If you're working with a data scientist or a machine learning expert, this will be their bread and butter, how much context overlap we actually do. But to be perfectly honest, I don't see them designing the next generation of intelligent apps, of productionized systems. It's developers. The tools are available to everyone. On top of that, be thinking about where you can actually begin to structure your reference data. Don't just have, hey, this is page 1, this is page 2, this is page 3. Actually put some structure and format to each of those references. If you've got a HTML page, if you've got something in Markdown, this is really easy to do. And funnily enough, it's just string processing at the end of the day. So you'll feel relatively comfortable with that. The other thing that I'll mention, and this comes from an actual customer use case because they were trying to abuse the tools they were given. If you have a massive large index of all these documents and only one particular document relates to a user, please don't try using vector search or hybrid search or semantic search to find that one particular document. Just put in a filter. Keep things simple. If you're only looking for documents for a particular year, put a hard and fast filter in. If you're only looking for documents that a user has access to, use group ID filters. We often get caught up in the world of let's add some additional metadata, some additional context to each of the documents to make sure I can retrieve them and find them. Funnily enough, a filter is the simplest approach to ensure you actually get what you want to see. This is just a generic call out and a 5-second rant. Please don't fine-tune models early. There are specific use cases where fine-tuning makes sense. And if you do not know what fine-tuning is, then you do not need to fine-tune your models. Everything that we've talked up to this point should be tried, tested, implemented, and you have a specific reason why that doesn't solve the problem before you ever reach for fine-tuning. For those that are wondering, what do I mean by fine-tuning? This kind of moves towards building your own model, changing the actual underlying weights. If you really want to have a look at it and management's like, no, we need our own GPT, we need our own model, navigate them to ChatGPT, OpenAI's website, and look at custom models there. Models start from a $1 to $3 million investment point for your first iteration. That is not something that every organization is going to say, yes, let's do that straight away before we've seen value. How many people here have seen a 429 response from a HTTP request? So I've sent something off and get a 429 back. Cool. This is going to be the hot response code of generative AI. It is too many requests. Funnily enough, we're limited by compute, how many GPUs we can cram into a data center. And you won't always have access to all the infinite capacity in the world that, hey, cloud was kind of meant to deliver. No, we live in reality. Data centers have limits. You need to be looking for and understanding too many request response codes when they come back. You need to be retrying in a meaningful manner and actually waiting, not just slamming these systems as hard as you can. And where possible, look at introducing circuit breaker early. There's no sense in sitting there waiting to get a 429 back if you've had a 429 for the past 2 minutes beforehand. The other thing I'll mention is we actually give some really nice quota controls in Azure OpenAI. So if you are like, hey, I want to make sure this thing doesn't run away from me, that I don't get $1 million costs overnight, you can actually force 429s to happen by lowering your quota. This is super cool, both for test environments where you want to make sure that you handle this behavior correctly, but also to make sure that you don't have bill shock at the end of the month. There is nothing wrong from setting your quota down low and then increasing it as you need. Cool. You should also be thinking about retry logic. Retry logic for 429s, retry logic for content filtering, retry logic for everything that comes back. Pulling back the magical curtain, all of this new generative AI stuff is just simply an API call. It's not actually that new from like an integration perspective. It's just another API you integrate with. So don't throw out things like retry policies. Have them as part of your design from day one. Other thing I'll mention, which this is highly topical depending on who you talk to, is, hey, one data center might not have capacity, but you know what? It's the US right now, and they're not, it's the US nighttime right now, and they're not awake. So let's go use some of their capacity as well in scenarios where we can actually have data that leaves Australian shores. But the whole idea of actually load balancing between multiple regions, multiple resources, means that you can serve requests in as low latency as possible. Just consider whether it is your application that does the load balancing or if you have an organizational strategy to do load balancing. I'm going to do a quick shout out here. Graham Foster, one of my co-workers, developed a really cool project called AI Central, which is focused around giving abstractions across multiple LLMs, multiple regions, multiple data centers, giving you one endpoint to call in an enterprise-ready way. All right, let's get into a couple of fun things. Monitoring. Who here likes monitoring? Who here doesn't know they like monitoring because they don't have monitoring? Cool. I was expecting 1 or 2 hands there, but that's okay. You don't need to put your hand up. Monitor everything. The first place I often talk about, especially when we look at user experience, is do you understand the timing of every single request that's happening? Do you know how long you're spending in LLM inference versus how much time you're spending preparing the data beforehand? We're going to talk about streaming in a second, but if it's taking 2 to 3 seconds to get to that first byte of the large language model coming back, it doesn't matter how fast we stream data out to the user, you're always going to be bound by that first, or time to first byte, if you will. Understand your timings, log your timings, monitor, and ideally keep an eye on them. If you're noticing your inference times are spiking and going super high, that's something to look into. Could be an attack, could be that you just need to change compute resources. Also monitor your failures. And this is what we're actually doing down the bottom right there. We're monitoring how many failures come back, how many times people are attacking it. This is helpful to understand the behavior of your system. If you are constantly having content filters being triggered off and blocking actual user responses, it shouldn't be the users that are telling you about it. You should know ahead of time when you're hitting those failure limits, those retry limits. And also, to be perfectly honest, log who's using what session ID. Even if you don't have users logged in that you can actually link a session ID back to, capture IP address, capture basic fingerprinting data. It is helpful if someone tries to abuse the system, you can actually begin to correlate between sessions. This is the one big slide that has the things that I wish everyone would capture, but absolutely no one captures, and we always have to do it after the fact. Monitor utilization. Not just from number of tokens, but number of conversations, number of messages per conversation, number of conversations per user. Understand how your users use your application. I've had 1 or 2 retail assistants now that have been changed the way they're designed, the whole user experience, because of the fact people were only asking one question and then closing it off. If they weren't getting their answer within that first question, they were just abandoning. They were just going off. So the system was changed to actually have more of a single answer response with more detail, rather than necessarily expecting everyone will ask follow-up questions. The last one, which is slightly more advanced, but I really want to throw it in as an explicit one because so many organizations are being caught out by this. When it comes to that pipeline that we're building, that end-to-end API, monitor any external calls as well. If you're using tooling, if you're having a large language model query a SQL database, know how much time it spends in the database versus generating the query versus analyzing the results. These very simple patterns for actually understanding timing means that when it comes back and says, hey, this takes 20 seconds to execute, if 15 seconds of that is your SQL database, there's no sense in trying to optimize the foundational model itself. Add in a global kill switch. This is something that I see especially for public resources, for public chatbots, especially anonymous ones. Have a way to shut things down. Seriously, it's actually really nice to have. Rather than necessarily having to go in, change code, pull out, or have a bad user experience, expect that the API will be down, gracefully recover from it. I'm going to go on a 30-second rant with this one. You do not need streaming when you get started. What do I mean by streaming? Those characters popping in one by one as they're generated. For those that have opened up the bot, looked at the app, that does not use streaming at all. Did you feel that it was not snappy, that it didn't come back straight away? No. The characters popping up on screen there are done entirely client-side. It receives the requests and it just starts typing them one by one as quickly as it can. There are cases where you will know you will need streaming. You don't always need it. Let's get into testing very quickly, because this is an area that I'm quite passionate about and would like to actually talk in a little bit more detail. You should be testing your generative AI. Generate sample inputs and outputs. Here we've got 4. To be perfectly honest, I'd be happy with 400. Have examples of what users are asking, and actually every time you make a prompt revision or every time you change your code, run through them all. Your first iteration can be a human reviewing it, checking, are these results actually relevant? Your second iteration will be using relevancy. Rather than having to have a human read through all the results one by one, there are some really nice frameworks to actually allow you to check if results are relevant, if they're not relevant, using very basic NLP. If you're looking at embedding-based BERT score, super cool. Funnily enough, it's that pattern we talked about before. I get one answer back, I get another answer back. How similar are these two things? Are we at least in the ballpark? What you will see organizations go to over time, though, is using generative AI not just for inference, but for test validation as well. Actually using a system prompt to say, given that this was the question, this was the answer that was produced, and this was the expected answer, how far off the mark are we? Beginning to actually use understanding of the responses and requests to test. The nice thing about this is it is incredibly fast to run, can be done at scale, and can not only be done on test data as part of test pipelines, but you can run this in prod as well. You can actually use this as a live smoke test, constantly evaluating the quality of the answers that come back. Where this is really handy is if you have constantly changing reference metadata. If someone goes in and deletes all your reference metadata, this is a great way to find out because it's a large language model telling you there are no relevant results, rather than a user screaming at you saying, hey, I couldn't find what I was looking for. This is another one, once again, that I'm quite passionate about, test prompt injection. In the same way we did all of those tests before, now multiply them by all of the different prompt injection attacks that are available today. Basically do a matrix of, here are all of my tests, here is all of my prompt injection techniques, and test every one of them. You'll probably hit a point where it will be too expensive to test every single iteration, but it's a great place to start. If you, as part of a testing pipeline, can validate that prompt injection has changed the behavior of my application, that's fantastic. That means you've actually tested before you've released and validated that you are protected. As I say, there's a repo with 600 plus prompt injection examples. If you've heard of like ChatGPT jailbreaks or Do Anything Now or Dan, those patterns are the basics for modern prompt injection. Use them, take advantage of them. They're out there in the open. If you're not testing against them, trust me, users will be. They love getting bots to say random things. All right, we're on the home stretch. Got a couple more. Decide early whether prompts are code or prompts are data. I see a lot of developers reaching for prompts as code, which I personally like. Having a release that not only represents the code and the logic, but the system prompt that will be used means that it's very simple to roll out, roll back, to know exactly what revision is being used, but makes it harder to iterate. On the flip side, if we have prompts as data, you need to keep track of exactly what prompt is in what environment at any point in time. And if all of a sudden you're changing your expected result versus what the prompt says to do, you're going to be in a world of trouble. So prompt as code, simpler, harder to iterate on. Prompt as data, easier to iterate, more chance to shoot yourself in the foot. A/B your prompts. Once again, if you're doing prompts as code and having it compiled as part of your application, this means 2 revisions sitting side by side. Allow your testers to actually trigger a particular prompt revision. Nothing new here. A/B testing is kind of just standard practice these days. If you're not playing with it now, generative AI is a great place to get started because testing the difference between 2 prompts is actually really, really useful. Finally, you remember that big metadata table we built up earlier on? Everything that we've just talked about, every bit of monitoring data should be part of that metadata table. You should know what prompt was used, what version of your application, what code release, what RAG options were used to actually include relevant metadata. Trust me, this will help you when you have a production issue wondering why a bot responded in a particular way. If you can take the message that was passed in, the data that was provided, and try and reproduce, it makes your life simpler. I've said it a few times. All of this is just an API. Like seriously, when you're getting started with generative AI, do not treat it as machine learning in that context. Just think of it as another API call that calls another API. That's it. We want to orchestrate how that happens. We want to make sure that results are relevant. We never want to trust the data coming in, nor do we never want to trust the data coming back out from the large language model. Validate, 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 and log everything. If there's nothing else you take away, it's just please log more. All right, last 4. And these are the fun ones. We've talked about prompt injection. But did you know you can actually get generative AI to begin attacking your own system? You can get generative AI to generate cross-site scripting attacks as part of responses. You can get it to generate SQL injection attacks without it even knowing. And if you're building SQL queries off what comes back from these models, you could possibly be in a world of hurt. And the funniest thing is it doesn't even need to be complex things. Literally asking, as I say, for the first example is a great one because I actually saw someone use this against one of my own demos. And luckily I was using inner text, not inner HTML. Funnily enough, nothing to do with Gen I, just basic developer practices. This catches people out, seriously. Vulnerability scanning, I will tell a very fun story about this. If you are not vulnerability scanning the APIs that you have, someone else is. I deployed a demo for a customer at 9:30 p.m., went to bed for the night, came back in the morning and had 200,000 conversations, each with a couple of hundred messages. Someone decided to run a Z and a Nessus automated scan against my API endpoints. So I had conversations, messages with every type of vulnerability scanner attack you can think of. The tricky thing is, because you can pass in some information and the large language model might say back, sorry, I can't help you with XYZ, that looks like a reflection attack to every vulnerability scanner out there. So they will just go into turbo mode and start just absolutely throwing as much as they can against your endpoints. Because you're doing safe AI practices, because you've got examples and JSON validation, and you're doing everything we've talked about so far, doesn't mean your application's safe. You still need to do proper security practices from the ground up. This is just a personal call out, and funnily enough, it is one of the reasons that I threw it in here was the last example that I gave. If you're building a proof of concept, put a North key on it. I've actually got some samples that I'll be releasing along with kind of references for this talk of how to do basic code-based authentication for pretty much every single language. If you have an endpoint that can get to a large language model, chances are people will find it. How will they find it? Well, if you use Let's Encrypt, someone will watch the certificate transparency logs and they now know your host name and they're now calling your APIs. 1,000,000 times in a night, bam, you've now stuck with the bill. So put authentication, authorization, or even just an API key around the proof of concepts you built. I will publish and release that. I don't think that's public yet, so not even worth taking a photo of. Last 2, be transparent, please. Say when something is AI generated. Say when it is generated by generative AI. Be honest with your users. You can do personalization and personification of AI, but make sure the user actually knows that, hey, this is not a human-generated message. It could potentially be incorrect and give them the ability to validate. Use AI responsibly, please. It's just kind of a plea from myself, and Microsoft has this whole big responsible AI thing that I highly recommend everyone should read. It is very, very long, but very important, especially over the next few years. But before we wrap up, I will leave you with pattern number 45. And this to me is the most important pattern because imagine every one of your users has seen this talk. Every one of your users is now trying to do prompt injection attacks, spam you with messages, fill your context with as many tokens as possible, is trying to do cross-site scripting and SQL injection attacks on every single request they send through. Treat every user this way. Treat them as Scott because, hey, you know what? If I find a public-facing bot, you can normally in 1 or 2 prompt injection attacks determine what model it's using, and from there, the world's your oyster. So the big question is, do you have the patterns to go to production? Here's the big slide of all the patterns, everything we've covered today. Who remembers everything that's on there? No, no one does. I mean, I keep having to look to the slide to remember what's actually coming up next. This has just been a tidal wave of information, and this has been a talk that I've wanted to give for so long because we need everyone to understand the importance of all aspects of generative AI when it comes to building intelligent apps. Not just the security tick boxes and the security theater, not just throwing in private networking because it needs a private IP address, but actually understanding what you need to get a solution to production. Now, hasn't been too many architectural diagrams. There's fantastic open source ones out there. I'm not going to repeat that. Things like Azure Chat, for example, are a great code-first example of how to implement pretty much all of this. So these patterns do exist. But this is a nice tick list to begin to go through and say, hey, have we considered X, Y, Z for our new application? So with that, we have officially hit an hour. So I am going to finish up there. Thank you for listening, and we'll do questions a little bit later. Thank you. And what is that? 2.5 million prompt tokens. Seeing as you could only put in like 100 to 250 characters, that's pretty wild over the course of an hour. And this is a couple of people in a room. We had, what is that? 74K completion tokens. I'm glad I set that limit low. Otherwise, you would have just ruined the budget that I have there. Hey, 2.8 thousand messages sent for people that were meant to be paying attention to a presentation. I'm pretty happy with. But the number that I really like, of the 2,800 messages that were sent, there were 584 errors, content filter validations, or retries that we caught and gave a good user experience because of everything we've seen in this talk. So it does actually work. And most importantly, I haven't seen a little notification pop up there to say that someone has managed to exfiltrate all 3 items. So I'll ask the question, did anyone manage to get the secret word back at all? No? Good. It means these patterns work. The tool name or file name by any chance? Awesome. That is fantastic. It means that some of these patterns actually work. I'll keep it up for a little bit longer if you want to keep on playing around with it, but I'm also releasing all the code open source so you can actually see what's driving the whole experience from today. Really quick? Yeah. And it's funny because it's doing all of that in the background. The other fun thing that, and this is why I love to blow people's minds, that doesn't use streaming. It's actually waiting for the entire response to come back from the large language model before we send it down to the user. The streaming experience you see is entirely client side. When the message pops up, it already knows exactly what it wants to say. But funnily enough, putting the characters on screen faster once you get them feels faster than waiting for something to be typed out step by step. So little cool UX tricks, but I'll stop there because we've gone over the hour. Thank you so much, and I'll stick around for questions at the end. Thanks.